And finally, dear grade 11 students, we reached the last training exercise about limits. And here we go with this function, x squared minus 6x plus 9 over minus x squared plus 5x minus 6. We have, of course, to study the limit of this function as x approaches the roots of the denominator that are 2 and 3. So the roots of the denominator are 2 and 3 either by using the calculator, as you see here. We have to choose mode 5 and we have to choose the quadratic form. The denominator a is minus 1, b is 5, and c is minus 6. Then the roots are 3 and 2, as you see here. Now we have to study the limit as x tends to 3 and as x tends to 2. First of all, we have to evaluate in the numerator and to see if we have an indeterminate form or not. Because whenever we have an indeterminate form, we don't have to study the limit at 3 plus or 3 minus. We just have to get rid of the factor that makes 0. Let's start, and here we go with evaluating 3 in the numerator and the denominator. We're going to get 18 minus 18 in the numerator and minus 15 plus 15 in the denominator, which is 0 over 0. That means that 3 is not only a root for the denominator, it's also a root for the numerator, because when we factorize the numerator, it's going to be x minus 3 squared using a certain identity. So 3 is a double root for the numerator. Now, by factorizing the denominator, it is going to be x minus 3 and minus x plus 2, not x minus 2, because a is minus 1. Because we start with minus x squared, then surely one of the factors should start with minus x. That's why we put x minus 3 into minus x plus 2, and if you want to make sure, just expand these two together and you will get definitely this one. Thus, the factorized form of minus x squared plus 5x minus 6 using its roots is x minus 3 into minus x plus 2. Now we have to cancel the like factors, x minus 3 with x minus 3. What remains up is a factor, x minus 3, and down remains minus x plus 2. Now finally, by substituting 3 up and down in place of x, we're going to get 0. So the limit as x approaches 3 after getting rid of the indeterminate form is 0. Then 3, 0 is the limiting point. Now let's continue and to see the limit above as x goes to 2. Now limit as x goes to 2. 2 is not a root for the numerator, then definitely we're not going to get 0 over 0 if we substitute 2. That's why we have to use the help of the sign table. Now the roots on the sign table, same as a, which is minus here or here, the same function. So same as a, which is minus, opposite to a, which is plus, and same as a. So same, opposite, same. Here is the region where 2 minus is, tending to 2 from the left. And here the region where 2 plus is approaching 2 from the right. Now all what we have to do is to study the limit at 2 minus and at 2 plus. Limit as x approaches 2 minus of this function, we substitute 2 in place of x. We have 4 minus 24 minus 12 plus 9. It is 1. So we have 1 in the numerator, and directly we put, as I keep telling you, 0 in the denominator. So why is it 0 minus? Because 2 minus is in that region where we have minus, so we have to put 0 minus. Then 1 over 0 minus approaches minus infinity. Similarly, for the limit as x tends to 2 plus of this function, again we have 1 above, and in the denominator we have 0 directly, but 2 plus is in that region, so we put 0 plus because we have a plus sign. And thus the limit as x tends to 2 plus is plus infinity. So we conclude that x equals 2 is a vertical asymptote. So the vertical asymptote is x equals 2 because the limit as x approaches 2, whether 2 minus or 2 plus, is infinity. And now we are going to see what's the meaning of the vertical asymptote and the horizontal asymptote graphically. Now what about the horizontal asymptote? y equals -1 is the horizontal asymptote because, again, uh, as x approaches infinity, so the limit as x approaches infinity of this function, which is x squared minus 6x plus 9 over minus x squared plus 5x minus 6, we just take the highest power from the numerator and the highest power from the denominator and simplify them. We are going to get -1. That's why we say that y equals -1 is a horizontal asymptote because it's the result of the limit as x approaches infinity. And as I mentioned, we call 0 limiting point. Now let's see this, the curve of this function. Here is the curve of this function. Okay, notice we have a vertical asymptote, which is x equals 2, and here is a horizontal asymptote, or the horizontal asymptote, which is y equals -1. So x equals 2. Notice that as we approach 2 plus, as x approaches 2 plus, the curve is going up to plus infinity. As we approach 2 minus, as x approaches 2 minus, is going down to minus infinity. Now, this is about the horizontal asymptote. As x approaches plus infinity, the curve is approaching -1, and as x approaches minus infinity, the curve is approaching also -1. So this is the horizontal asymptote, and this is the vertical asymptote for this curve.